Hello student, in this video we will be discussing about block diagram of FDM. Frequency Division Multiplexing, FDM. What is multiplexing, sir? First point, transmission of more number of signals through a single channel itself is called multiplexing. Why this multiplexing concept came, sir? For example, if you want to transmit a data between, for example, two countries, there are plenty of voice data will be there, means like video, data, audio like. If you want to make them separate, it's a very costly and complex. Just like you can take an example of your TV. From dish to TV, how many cables are there? One. But how many channels will be there? Hundreds of channels. For example, if you want to keep a separate cable for each and every channel, then how the situation will be there? So multiplexing is one of the important thing that to make the things are less costlier and simple. So transmission of more number of signals through a single cable itself is called multiplexing. Now here, first concept I am discussing about the frequency division multiplexing, especially for the continuous time signals we will call as a FDM, and for digital signals the time division multiplexing. In frequency division, the meaning after completion of this FDM you will understand. So by the name itself you need to understand that we are going to be dividing the frequency of what? The total channel. The total channel bandwidth we are dividing, and we are keeping our messages in a particular slots, in a particular frequency ranges. Like if you see your TV cable also, each and every channel will have a specified frequency range. So whenever you are clicking on the remote, the specified frequency will be there. Now, as the simplest diagram here we are going to be discussed, coming to the FDM. Here, multiple number of signals we can transmit. Multiple means I cannot show you some 100 or 1000 here. For example, for our understanding, I am taking some 3 messages. Let's take, for example, the 3 messages. The first one is M1 of T, like the second one M2 of T, like the third one M3 of T I taken. And another point I want to explain you here. For example, we are sending the voice of 3 persons like Ramesh, Naresh, Suresh. Ramesh, Naresh, Suresh. 3-person voices I am transmitting. You can take the voice of any person. I already told that the frequency range is common. 300 to 3.4, 300 to 3.4 like that. So the practically messages frequency spectrum is almost the same. Their strength values are different, their words are different, their programs are different. Like even the TV also, hundreds of channels are there, but whatever may be the channel if you tune, only 2 components, audio and video. So for our ease of understanding that, all the messages are having same frequency range I am taking, but just for our understanding, I am taking some different shapes to show that all these messages are different. For example, all are from -5K to +5K. If you are not interested, -1 to 1, 2 to 2, 3 to 3. Like any equal range I am taking to show you that all practical messages occupying spectrum is same. Their amplitude strengths are different, words are different, but spectrum almost the same. Anyhow, if you want to go for multiplexing, student, modulation is must and should. Modulation is must and should, I already told. Are you understanding my point or not? Modulation must and should. So, what is the next block we are having, sir? The next block is, sir, modulator, sir. So modulator 1, For this one, we are using the carrier frequency FC1. For the second one, sir, modulator 2. For this one, we are using carrier frequency FC2, sir. Like the next one is modulator 3. For this one, we are using some different carrier, which is FC. After going for a modulation, we can give to the channel by adding all these three. So let's take a adder here. So all we are giving. Got my point? Now, then we can give to the channel. Even the channel also, another modulator also we can use if you want to send to another level. Are you getting my point? Whether you can use or not, that's not the thing. Next, we are giving to the channel and we will transmit to a distance how much we want. And coming to the receiver end, first we need to separate each and every modulated signal. In each and every modulated signal will be exist in a specified band. So we have to separate those bands. So what is the first block we are having, students, is nothing but a bandpass filter. Bandpass filter 1 to separate first modulated signal, bandpass filter 2 to separate second modulated signal, bandpass 3 to separate third modulated signal. So this cable will be connected to all these. Now it will separate each and every modulated signal. After separating each and every modulated signal, we will get back our original message. We done the modulation there. So here we are using demodulation. Let's take the demodulator 1 to get our message M1 and given to demodulator 2. We will get M2. Like demodulator 3. I will get some M3 of it. Getting my point or not? This is the block diagram of a FDM, what we have. Now, this frequency division multiplexing, I am explaining you in the 4 cases. Clear? This FDM, I am going to explaining in the 4 cases. Let's take the first situation, case 1. For example, students, in case 1, I am saying that no modulation used, no modulation done. If we are not using any modulation, what is happening? Let's see. Are you getting my point or not? Now, what are the problem we are having? So, if you want to go for multiplexing, modulation is must and should. If you are not using modulation, what is happening? Let's see. All messages are directly we are giving to the channel. Now I am writing the channel spectrum. All messages are directly giving to the channel. Now I am writing the channel spectrum. If you see there, how many signals we are multiplexing? We are multiplexing the 3 messages. So all messages are directly given without doing modulation. Means where is the first one occupied? Occupied from minus 5k to plus 5k. Where is the second one is occupied? Second one also say minus 5k to plus 5k. Where is the third one occupied? Is minus 5k to plus 5k. Means just like 3 subjects are going on simultaneously in the same classroom, same timing. Like signals, communication, maths. All faculties came, all are taking the class simultaneously. Then which subject you will understand? No subject. Because interference. So, if you directly transmit all audio messages or all voices directly to the cable, you will have a problem of interference because all are having almost same frequency band, I am saying. So you are having a problem of interference. So that's why what I am saying, if you want to go for if you want to go for multiplexing, modulation is must and should, otherwise interference. So I am going for a second case, case 2, modulation done. But let's see, I am using same carrier frequency. Actually, we have to use different. Suppose if I use the same carrier frequency, let's see what is happening. Actually, we have to use different, so that's why I written FC1, FC2, FC3 like that. Suppose if I use the different, then what is happening? Let's take we are doing some DSBSC modulation, for example. Actually, in FDM, for transmission of voice, we are using the SSBSC. To write the spectrum in easy manner, I am saying all are DSBSC modulation. So first one is shifted to FC. All are same carrier frequency. FC plus 5K, FC minus 5K. Where is the second one, sir? Second one is also same range. For the third one also we are using same carrier frequency. Means still here also we are having a problem of interference. Understand my point or not? Got my point or not? So, first case is suggesting that you need to go for modulation. Second case is saying that must and should you do you have to take the different carrier frequencies. Are you getting my point? So, I will take the third situation. By taking different carrier frequencies, then see how the spectrum, then later you will understand what are the requirements of these bandpass filters and how we have to take the carrier frequencies to make to avoid the undesired components from the BPF, bandpass filters. So this I am erasing for our understanding to make the space, not understanding, to make the space on the board. I am erasing this. And a third situation, what I told, modulation done, as well as case 3, modulation done, and a different carrier frequency used. Let's see the channel spectrum. Different carrier frequency mean like FC1, FC2, FC3 I am using. FC1, FC2, FC3. Now see, first one is occupying from where to where? I have taken minus 5K to plus 5K. For that one I am using the carrier frequencies FC1. This is FC1 minus 5K, FC1 plus 5K. Second one, I am using FC2. So this is the FC2. Third one, FC3. This is the FC3. Then what about this value? FC2 minus 5K, FC2 plus 5K. FC3 minus 5K, FC3 plus 5K. How to select this FC1, FC2, FC3 we will see. But anyhow, try to understand. I take an FC1, FC2, FC3 in such a manner that I got the spectrum like that. If I got the spectrum like that, is there any interference effect, sir? No. All are well separated. And I can also say here, this FC2 is far greater than FC1 plus 10K. Like in the similar manner, FC3 is far greater than FC2 plus 10K. You can observe. From here to here, FC2, up to here, FC1 plus 5K, this is another 5K, so 10, this is some gap. So I can say FC2 is far greater than FC1 plus 10K. Understanding my point or not? And now, I will take the fourth case also for our reference to analyzing the final. What I am doing in the case 4, in the case 4, I am taking FC2 is exactly FC1 plus 10K and FC3 value is FC2 plus 10K. Then I am drawing the spectrum. If I take the frequency components like that, is there any gap available, sir? No gap, sir. So where is the first one? FC1 minus 5K2. FC1 plus 5K, of course this is FC. And the second one, sir, this is FC2, this itself is also, I'm writing here, FC2 minus 5K. Next, this is FC3, FC3 plus 5K, this point itself is, I can say FC2 plus 5K as well as FC3 minus 5K also. If I am not giving any gap exactly, if I take C from here to here, up to here FC1 plus 5K, another 5K, because FC2 minus 5K to FC2 plus 5K, exactly FC2 is nothing but FC1 plus 10K. Up to here, that is nothing but FC1. Even if you see the fourth case also, is there any interference effect, sir? There is no interference effect. So, I am using fourth case and I am transmitting. Coming to the bandpass filters, first bandpass filter where to where I have to design? FC1 minus 5K to FC1 plus 5K. Like the second one, FC2 minus 5K to FC2 plus 5K. Like the third one, FC3 minus 5K to FC3 plus 5K. Got my point or not? Now, first bandpass filter where to where I designed? Here to here. Is it designed the filter with sharp cutoff frequency? Not possible. Some transmission band will be there. So at the outputs of a filter, some of the undesired frequency components are coming. So that's why, let's see. Here I maintain some gap. If you maintain a gap, what is happening is, even the filters are not ideal also. No undesired frequency components. That gap itself is called, students, guard band. So we need to make sufficient guard band between the adjacent messages. Then there is no undesired frequency components from the bandpass filters. Anyhow, no interference problem. So finally, in FDM, how we have to select the carrier frequencies? We have to select the carrier frequencies in such a manner that there exists a proper space called guard band. Then there is no interference and no adjacent channel interference, means there is no undesired components from the BPF. Even if you see the practical FM radio, the guard band is 20K. Anyhow, here 3 messages I am multiplexing. How many guard bands will be there? 1 and 2. 3 minus 1 is 2. If you multiplex n signals, the number of guard bands are n minus 1. You have to choose that properly guard bands depending upon the filter characteristics. Like how many signals if you want, you can multiplex. FDM is little bit complex when compared with the TDM, because here number of modulators and bandpass demodulators. FDM is slightly, TDM is less complex when compared with the FDM. Clear?